Welcome back to another lesson in MCR3U. Today we'll be looking at vertex form. So here, if we're looking at finding the optimal value, what that means is that we are looking for the maximum or minimum value. So maximum or minimum value. Okay, and we know that if it opens up, so if the parabola opens up, that means here we have a minimum value. So if it opens up, we have a minimum value. And if it opens down, we have a maximum value. Remember, the direction again is determined by the A value. So, and that helps us determine again whether we're looking for uh, maximum or minimum value. So here, when we look at the definition, the optimal value occurs at the vertex. It is the maximum or minimum value depending on the situation. And so here it says, an example, state the optimal value of y is equal to -2 x plus 1 squared minus 3. We know that the vertex occurs at the h and the k value. And here what we're really focused on is we're focused on the y value of the vertex. It's the y value of the vertex here is equal to -3. So the optimal value would be y is equal to -3. What you shouldn't do is you shouldn't just list the vertex. So you shouldn't list -1 and -3 and indicate that this is the optimal value. That is incorrect. And so here we have y is equal to 5 over 2, x plus 3 over 2 squared plus 5. So again, here we see that our y value of the vertex is equal to 5. So here we write like, our optimal value at y is equal to 5. The reason is if you look at the graph, so if we graph this, if we here it opens up at a value of 5. So here, even if we open it up like this, we're looking at this line of the minimum. We see that that value would be, for example, y is equal to 5. That's why we don't indicate it as coordinate, we indicate it as a line. And so if we're looking to convert from standard form, which is y is equal to ax squared plus bx plus c, to vertex form, which is y is equal to a x minus h squared plus k, the first thing we want to do is we want to determine the axis of symmetry. And there's two ways, again, to determine the axis of symmetry. First, you can average the roots of your quadratic equation. And then, so here, if you find the two roots, you want to average them. And again, so what that means here, again, is the axis of symmetry is equal to adding the x-intercepts and dividing by 2. Another way to find it is also looking at h is equal to -b over 2a. And we use this formula again. So use this formula here, again, when it's in standard form and we have our b and our a value. So here we want to use this in standard form. Once you find the value, either adding the x-intercepts or the roots and dividing by 2, or using -b over 2a, then we're going to substitute the axis of symmetry into the equation to find the optimal value of k. And then you want to rewrite the equation in vertex form with the value of a. And remember, the value of a and same stays the same for all three forms. quadratic equations. Okay, so here it says to find the optimal value of the function and rewrite the equation in vertex form. And so here we have negative 5t squared plus 30t plus 10. So here we know that negative 5 is A, 30 is B, and 10 is C. And so here we can use h is equal to negative b over 2a. So that will give us negative 30 over 2 times negative 5. So that gives us an answer of 3. So our h value is 3. And what we want to do is we want to sub it back into the equation. So we'll sub this back into the equation. Y is equal to negative 5 times 3 squared plus 30 times 3 plus 10. And here we'll get an answer of 55 when we solve it. So we know that our h value is 3 and our k value is 55. So therefore, if we rewrite it, we see that we keep our a value. So we rewrite it in vertex form. We keep the a value, which is negative 5. We see that our h value is 3. And we see that our k value is 55 after subbing it back into the equation. And so here we have y is equal to 1 over 2x squared plus 3x minus 2. So do the same thing here. H is equal to negative b over 2a. Here, negative b is negative 3 over 2 times 1 over 2. So here we get an h value that equals to negative 3. So here we're going to sub it back again into the equation to find the k value. So here we have the y is equal to 1 over 2. We can either write it as y or we can write it as k. The situation, let's write it as k value here. So 1 over 2 times negative 3 squared plus 3 times negative 3 minus 2. Here we'll get 9 over 2 minus 9 minus 2. So it'll be 9 over 2 minus 11, which is equal to negative 13 over 2. So therefore, our equation is y is equal, and we keep our a value, which is 1 over 2, x plus 3 squared minus 13 over 2. Okay, so let's continue here. So it says a parabola has a y-intercept of 2. And it's important to indicate in these types of question what information is provided for you and what each form or what each quadratic form provides for you. So we know that in factored form, so factored form, we're given the roots, vertex form, given the vertex, and then for standard form, we're given the y-intercept. And that's unique for each of the different quadratic forms that we're looking at. So here, so the parabola is a y-intercept of 2, which means that just here we're going to use standard form. It contains the point negative 1 and 1 and negative 4 and 10. It says determine the equation of the parabola. So here, again, if we write standard form, it's y is equal to ax squared plus bx plus c. And we know that the c value is the y-intercept. And so if we set that in, we get y is equal to ax squared plus bx plus 2. And here we're given two sets of points. So here, if we sub in -1 and 1 into the equation, we get 1 is equal to a minus b plus 2. We move the positive 2 over, we get a plus b is equal to -1. So that's our first equation. In our second equation, if we sub in -4 and 10, that 10 is equal to 16a minus 4b plus 2. Here, if we move the 2 over, we get 16a minus 4b is equal to 8. To simplify this, we'll divide everything by 4. So we get 4a minus b is equal to 2. So we have two equations, which means we have a system of equations. And to solve for a system of equations, remember there's two ways. Solve for system of equations. And remember there's two ways to do that. First way is by substitution, and the second way is by elimination. And regardless of which way you do it, you should get the same answer. Here, we're going to use elimination. So we'll take equation 1, which is a minus b is equal to -1. And we'll take equation 2, which is 4a minus b is equal to 2. Here we're going to subtract. And we'll be given -3a, and the b's will cancel out, is equal to -3. So therefore, a is equal to 1. Once we do that, we can sub it into any equation. So here we'll sub into equation 1. So here, if 1 minus b is equal to -1, negative b is equal to -2, b is equal to 2. And so therefore, our equation will be y is equal to 1x squared, or just x squared, plus 2x plus 2. Okay, let's keep going. So here we have a parabola that has a y-intercept of 7. So again, gives us the y-intercept, so we're going to use standard form. And contains the point -2 and 11 and -8 and -1. Determine the equation of the parabola. So here again, standard form, y is equal to ax squared plus bx plus c. Now here our c value is equal to 7. And so if we rewrite that, y is equal to ax squared plus bx plus 7. And so we're given again two sets of points, one at -2 and 11, and another one at -8 and 1. So let's sub in first -2 and 11. So 11 is equal to 4a minus 2b plus 7. Move the 7 over. We get 4a minus 2b is equal to 4. We'll divide everything by 2 here to simplify the equation to 2a minus b is equal to 2. So that's our first equation. 2a minus b is equal to 2. Our second equation, if we sub in -8 and -1, will be equal to -1 is equal to 64a minus 8b plus 7. Move the 7 over, we get negative 8 is equal to 64a minus 8b. Here we'll divide everything by 8. We get 8a minus b is equal to negative 1. Two equations, two unknowns. Again, substitution or elimination. Here, we'll use elimination. So here we'll take equation 1, which is 2a minus b is equal to 2. And we'll take equation 2, which is 8a minus b is equal to negative 1. And we will subtract the 2. Here, 2 minus 8 will get negative 6a. The b's will cancel out. And 2 minus minus 1 will give us 3. And so here a will be equal to negative 1 over 2. Now again, we'll sub back into equation 1. Again, you could sub into equation 2 as well to give you the same answer. So here we get 2a minus b is equal to 2. Sub in negative 1 over 2. We'll get negative 1 minus b is equal to 2. We'll get negative b is equal to is equal to 3. Yeah, negative b is equal to 3. And so b is equal to negative 3. So therefore, our equation y is equal to negative 1 over 2x squared minus 3x plus 7. Okay, so this next question here says a parabola has an axis of symmetry at x is equal to 3. So axis of symmetry means that that provides us with the x value of the vertex, so which means that we're going to use vertex form, and which means that the h value is equal to 3. And so here we're given 2 points, and so it says find the coordinates of the vertex. And so again, in vertex form, we know that y is equal to ax minus h squared plus k. We have the h value here, so we'll sub that in. We get y is equal to ax minus 3 squared plus k. First equation, we have points 2 and negative 3. Sub that into the equation. We have negative 3 is equal to 2 minus 3 squared plus k. So here we get negative 3 is equal to a plus k. So that's our first equation. Our second equation, sub in negative 1 and 12 into the equation. We get 12 is equal to negative 1 minus 3 squared plus k. 12 is equal to 16a plus k. Again, two unknowns, two equations, system of equations here. So again, our first is negative 3 is equal to a plus k. And here our second equation is 12 is equal to 16a plus k. Here we'll take the two equations, we'll subtract them. Negative 3 minus 12 will give us negative 15. A minus 16, or a minus 16a would be negative 15a, and then the k's would cancel out. So here we see that a would be equal to 1. Take the a value, sub that back so into equation 1. Here we -3 is equal to a plus k. -3 is equal to 1 plus k, and therefore k is equal to -4. And so therefore, our final equation will be y is equal to x minus 3 squared minus 4. Okay, and then this last question here says a golf ball is hit and stays in the air for 6 seconds. The ball reaches a maximum height of 40 meters. How high is the golf ball? So here we know is that it stays in the air, so it starts at 0 and stays in the air for 6 seconds. So it lands there. We know that we're given that it reaches a maximum height at 4 meters. So it reaches a maximum height at 4 meters. If we take our two x-intercepts, we know that the middle, so so the axis of symmetry is equal to 0 plus 6 divided by 2 is equal to 3. So at 3 and 40, that will be where the maximum or the vertex is. So 3 is right here. So at 3 and 40, that's where the maximum is. So 340. So here we'll have a couple of let statements. We'll let h represent the height of the ball in meters. And we'll let t represent time in seconds. Okay, so here we know that the equation would be h of t is equal to a t minus 3 squared plus 40. And so first we have to find our a value. So here we'll just sub in one of the points. So easiest point to sub in is 0, 0. And so 0 is equal to a 0 minus 3 squared plus 40. Here we get -40 is equal to 9a. A is equal to -40 over 9. So here our equation is h of t is equal to -40 over 9 t minus 3 squared plus 40. And here we're trying to find, again, how high the golf ball is after 5 seconds. So here what we want to do is we want to sub t is equal to 5. Here we'll get h of 5 is equal to -40 over 9, 5 minus 3 squared plus 40. So that's equal to -40 over 9 times 4 plus 40, which is equal to -160 plus 360 over 9 if we make it into common denominator, which is equal to 200 over 9. So here, if we write their first statement, and therefore 5 seconds, golf ball reaches a height of 200 over 9 meters. And if we approximate that, that's approximately 22.22 meters here. Here, if we look at our graph, we can just sketch it a little bit. So again, follow this parabolic path starting at 0 and then landing back at 6.